Once you're done setting up your project, the next step is to configure it. You can set up a configuration that may be a wind farm, solar plant, or a hybrid power plant. In this video, we'll look at a wind-specific one. We start by clicking New Configuration. Give your configuration a name, and if necessary, a short description of what you're trying to achieve with your design. Review and confirm the status. And if you know it already, set it as a baseline or your best configuration. Please note that what you select here will determine the results you see for this project on the portfolio page. Next, we start defining our design. As you might know already, for wind conditions, we use a UL-based dataset as a standard for early project phases. Please note that the wind speed that you see here is interpolated at a hub height of 100 meters. If you would like to explore the site conditions some more, you can do that too. In fact, on this page, if you have access to more accurate measurements, let's say from a met mast, or you have information from a neighboring wind farm, you can add that as a custom dataset to improve the accuracy of your results. I'll go back to my configuration page now. Select the commercial operation date. By default, the project lifetime is set to 25 years for wind projects, but you can change this to a different value if you need to. I will stick with the default for my design. Next, we specify what kind of and how many turbines we're going to use on our farm. You can select a turbine from an OEM or choose a custom turbine if the standard models do not meet your specific requirements. When selecting a custom turbine, you need to specify the rotor diameter that best fits the wind conditions and space of your project site. Specify the rated power of your turbine. This should align with your project's energy production goals and grid integration capabilities. If you select OEM, then you have the ability to select one of the turbines from our comprehensive catalog. In the drop-down menu here, you will see that we label turbines as recommended, suitable, and not suitable. And this is done by matching the wind speed that the turbine is designed for and the wind speed at your site. I will select the Enercon turbine for my wind farm. If you click on the WTG details, you can have a look at the specifications for the wind turbine you've selected. This can be a critical resource when planning and configuring wind energy projects in Nash Dev. Each parameter directly influences the design and efficiency of the wind farm. Next, setting the appropriate hub height is essential for optimizing the wind resource capture at your specific site, as wind speeds can vary significantly with changes in altitude. By default, it's set to 100 meters. But you'll see that as I change this value, the wind speed for the project is interpolated again. And now it shows a different value. And when the wind speed changes, Nash does another check to ensure that the turbine you've selected is suitable for that wind speed. For a quick setup, you can choose no layout and proceed fast by simply providing the number of turbines you want to place on your wind farm. We will look at the detailed layout shortly. For now, I'm going to add 5 turbines to my farm. Next, let's have a quick look at the settings, losses, and cost assumptions that have an impact on the results with this specific configuration. Under Settings, you can see the default settings that we're using to simulate and predict the behavior of wakes within the wind farm. The decay factor is set to 0.07 by default, and it indicates the rate at which the wind speed recovers as it moves downstream from a wind turbine. Next up, you review the wind losses assumptions. These assumptions are crucial for accurately estimating the expected output and efficiency of wind turbines within a project. So, if you happen to have more accurate information specific to your project, feel free to override the default values here. But if you don't, it's best to stick with the default. The same goes for cost assumptions. For wind energy projects, we use default values for OPEX and CAPEX provided by Wood Mackenzie, and these have been validated by OneTech too. Note that if you want to override these values, you've got to ensure that they are expressed as euro per megawatt. You see here that the discount rate used for calculating the net present value is 8%. You can click on the Go Back to Default button if you make any changes that you don't want and want to start over again. Hit Save, and Nash Dev will start computing the results for our configuration. Now, while we wait for our results to be calculated, let's go ahead and create a new configuration. I can see the key metrics for my first configuration already. Now, this time, instead of starting from scratch, I will simply duplicate my existing configuration as a starting point. Click on Setup, and I can start making changes to create a new configuration. I start by renaming it. This time around, I would like to get a bit more specific with where I put my turbines. So I'll select the detail layout option. Please note that this means a longer waiting time for results, as the tool generates a high precision wind map for your location. But that also means that I'm getting more precise with the calculations. Click Create Layout on Map. As you hover over different points on this map, you will see that the displayed wind speed changes. White or lighter shades of blue indicating lower wind speeds, and darker blue indicating higher wind speeds. Having this information on your site helps you to position the turbines accordingly. You have the option to upload a file to bulk add turbines to your farm. In this case, however, I will add mine by placing them directly on the map. I click on Add New Turbine to place one on the map, and then I click a few more times to add more turbines. I can then drag them to a position that I like. When looking at placing my turbines, I can click here to check out the main wind direction shown on the wind energy rows here, which is very valuable information that will help me decide where to put my turbines, because I would ideally position them perpendicular to the main wind direction to maximize energy capture. A good layout would also involve positioning the turbines at the right distance to each other. The green circles here indicate that the wind turbines meet the minimum spacing requirements that are by default set to 4D, which is 4 times the rotor diameter. If I go to the satellite 3D view now, I get a visual impression of what my wind farm might look like. I think that's pretty cool. Another reason why a detailed layout is valuable is because once you define the position of the turbines, Nash Dev also calculates wake losses based on the position of the turbines, again, making your results more accurate. Let us now quickly explore a scenario where you happen to have turbines in the vicinity of your project. Our neighboring turbine functionality comes in handy in this case and allows you to incorporate neighboring turbines into your layout for more accurate impact analysis. You will see on this page that you can get rather specific by providing the rotor diameter, rated power, hub height, and minimum spacing between your neighboring turbines. Similar to what we did for our detail layout, you start by clicking Add New Farm. Click Add New Turbine to start placing them on the map directly, like we did before. Again, you do have the option to upload a file to bulk add your wind turbines. Additionally, you can also mark these turbines as active or inactive and see the difference in your results. Now, let's go and see the results for our configuration. The 3 graphs here at the top show me how much energy I can expect to produce with my project, the capture price, which is the average price per megawatt hour expected for the electricity produced, and the revenues I can expect for the lifetime of the project. You can see that even though the annual energy production remains relatively stable over time, indicating that the farm is expecting to produce a consistent amount of energy each year, the capture price, and hence the net revenue, decline at first and then stabilize. This is to be expected as more renewable energy projects come online the supply of renewable energy increases, potentially driving down prices. Other factors driving down prices may be technological advancements, government policy changes, inflation, and other economic factors, thereby leading to a decrease in the revenue generated by the wind farm over time. At the bottom here, you can see other important metrics such as the capacity factor, LCOE, LVOE, and the present value of energy at the gross and P50 level, helping you evaluate the potential return on investment and hence make informed decisions about funding the project. Under lifetime data, you can see the numbers for energy production, capture price, and revenues broken down by each year of the lifetime of the project. Under the wind production tab, you can see how we get to P50 values with a breakdown of all the losses that are factored in. You can see that for any year of the project's lifetime by selecting the year from this drop-down menu. You can also view your results at the wind farm or turbine level. When I click on turbines, I can see how each of my turbines is performing and the wake effect specific to each turbine. When I click Show on Map, I get a visual impression of how my turbines are doing, with dark green indicating the best performing and red indicating the worst in terms of net annual energy production. At this stage, I can choose to go to the layout of my farm and play with the positioning of my turbines to tweak and refine my configuration some more and see the difference in results. For now, I will go back to my results page. You can also download the results and other project information. And that is how you create your wind configurations in Nash Dev. Once you have a few configurations, you can compare them by lining them up side by side. You can click on each of the key metrics for more detail. You can also filter the configurations you want to compare based on different criteria such as status, project type, site conditions, number of turbines, etc. You can also choose to see the delta between a certain configuration to the baseline configuration. And that's that for now. You now know how to define specific parameters in the design of your wind farm and see the difference it makes on your results, helping you make informed decisions about your project. Thank you for watching and happy project planning!